Hi everyone, I'm Nikita Gupta and I'm in the Period 6 Physics Honors class. Today I'm going to talk about Ernest Rutherford, one of the most well-known physicists known to man. He was born on August 30th, 1871 in New Zealand. He had three other siblings. Rutherford studied in many colleges and institutions, such as the ones you can see here, and he died in Cambridge on October 19th, 1937. His ashes were burned in the Westminster Abbey, just west of Sir Isaac Newton's tomb and that of Lord Kelvin's. Ernest was a graduate of physical science and mathematics, and he was also a research student of famous J.J. Thomson. Throughout his life, he became the Langworthy Professor of Physics in the University of Manchester, chairman of the Advisor Council, and many more. He was very involved in the scientific community. Rutherford's first researches were concerned with the magnetic properties of iron exposed to high-frequency oscillations. He was the first to design high-original experiments with high-frequency alternating currents. He also invented a detector for electromagnetic waves, an ingenious magnetizing coil containing tiny bundles of magnetized iron wire, and he eventually reported the existence of alpha and beta rays in uranium radiation. The discovery of radioactivity. He studied the absorption of radioactivity by thin sheets of metal foil and found three components: alpha radiation, beta radiation, and gamma rays. He said that the alpha was absorbed by a few thousandths of a centimeter of metal foil, the beta could pass through 100 times as much before it was absorbed, and gamma could penetrate as much as several centimeters of lead. Here's an example of what it looks like, with the alpha particles, the gamma rays, and the beta particles. After studying radioactivity with uranium metal, he decided to use gold foil. Him and his assistant would count flashes of light given off by a zinc sulfide screen to see the alpha particles and the way it hit. They found that the narrow beams of alpha particles were broadened when it passed through a thin film of metal, and they discovered that the particle had mass and moved rapidly. The positive charge and mass of the atom were concentrated in a small fraction of total volume. And they also came up with a calculation that determined the radius of the nucleus was at least 10,000 times smaller than the radius of the atom. Here you can see the gold foil experiment and how much there is extra space outside of the nucleus. Most of the mass of the atom was contained in the small nucleus, and that the rest of the atom was mostly empty space. Experiments done in Rutherford's laboratory showed that when alpha particles are fired into gas atoms, a few are violently deflected, implying a dense, positively charged central region containing most of the atomic mass, as you can see here. He also had something very interesting called magnetic viscosity. He had a time apparatus capable of measuring time intervals of 100,000ths of a second. Some of his accomplishments were obviously the Nobel Prize in Chemistry in 1908 for his investigations into the disintegration of the elements and the chemistry of radioactive substances. He was also the elected fellow, he had many medals, and he was also very involved in the society. He has published several books such as Radioactivity, Radioactive Transformations, and many more. In addition, he also discovered that radioactive elements undergo decay over a certain amount of time. By this, he unleashed the power of the atom, and to this day that power is being harnessed for both beneficial and destructive processes. Shortly after World War I in 1920, Rutherford proposed the name proton for the positively charged particles in the nucleus of the atom. He also proposed that the nucleus contained a neutral particle, eventually called a neutron, and he identified the alpha particles as the helium nuclei. Some interesting facts was that he is listed in the Dictionary of New Zealand Biography as the world's first successful alchemist. He won a Pulitzer. He is also on the New Zealand $100 note. There is an element called Rutherfordium named after him. He has craters on Mars and the Moon named after him, and he also has some commemorative stamps in 3 countries. Ernest Rutherford is a great physicist, and without him we would have no idea about what the nucleus and an atom would look like.